Solving equations. In this video, we'll throw back to a simultaneous equation that we solved way back in the algebra section. This time, we'll do it using matrices. And here's your checklist, and that is to solve simultaneous equations using matrices. Now, if you cast your mind way back to the algebra section, you'll vaguely remember us tackling this simultaneous equation. Let's see how we can solve it using what we know about matrices. Now, the first step is to formulate the problem using matrices. So how I'll do this is that I'll have one matrix for constants, one for the variables, and then one more for the values on the right-hand side. Notice that if I were to matrix multiply the left-hand side, I would get back the original equation. Now, our second step is to find A inverse. A here is the matrix containing our constants. Let's start by calculating the determinant. So we have 4 by 1 minus 2 by 1, and this gives us 6. Now we move on to the adjoint. Now the adjoint is found by swapping A and D and then switching the signs of B and C. So we have 1, 2, minus 1, and 4. So altogether, the inverse is 1 over 6 times 1, 2, minus 1, and 4. Now step 3 is to left multiply both sides by A inverse. So here's our step 3, and A inverse cancels with A on the left-hand side. So here's what we're left with. All we need to do now is to simplify our equation with matrix multiplication. So let's do row by column. So we add 1 by 10 to 2 by 4, and that gives us 18. Next, we add minus 1 by 10 to 4 by 4, and that gives us 6. Now we scalar multiply by 1/6, and we get our final matrix of 3, 1. Therefore, x is 3 and y is 1, just like we had before. Thanks for watching. You can subscribe here if you want to get the latest from the Caribbean Scholar YouTube channel, or if you're ready, you can use the link in the description to hop onto our website and sign up for one of our premium courses.